Hi friends, good morning. Yeah, welcome to live streaming from Universal. I'm physics faculty in Universal. My greetings to you. And the assignment given to me, my friends, are three important lessons from mechanics, from classical mechanics. And they are laws of motion, work energy power, and rotational motion. I have almost some 10 questions each from each chapter. And we'll be discussing first 10 questions from laws of motion. So without wasting your time, because it's already late, we had some initial glitches, technical glitches in the beginning. So sorry for that. Sorry to keep you waiting. And without wasting your valuable time, let me go to my first question. And a few first questions appearing will be based on questions from laws of motion. And you know, all these three lessons are from your first year syllabus. Let me go to the first question. Let me read it for you. I hope my audio is clear. Okay, let me go to the first question, question number 1. Two bodies of mass 4 kg and 6 kg are attached to the ends of a string passing over a pulley. The 4 kg mass is attached to the table by another string. The tension in the string T1 is... You have to take actually the value of G as 9.8 exactly, but we'll make certain approximations in the beginning at least. Now look at the figure. You can see that there is a 6 kg hanging on one side. On the other side, there is actually comparatively a smaller mass, 4 kg hanging. But in order to balance that body, there is a string attached here, without which the system will not be in equilibrium. This string is essential here. If you cut the string, you know, certainly this 6 kg will go down and this 4 kg is likely to rise up. So in order to balance the whole system, there is a string attached here. They ask you, what is the tension in this string, T1, that is to be determined. So let's do one thing. Let us see what are the forces at play here. I'll just give you the forces, important forces acting on the system. I begin with mass 6 kilogram. This 6 kg experiences a weight. You know that mg is the weight of 6 kg and g is actually 9.8, but for convenience I'm taking g as 10 here. Finally, we can approximate it. Actually, I'm taking g as 10 meter per second squared, even though it is 9.8 exactly. Okay, I'll make certain approximations in the beginning at least. Okay, 6 kg has its own weight which will be acting downward, and that 6 kg has approximately 60 Newton. It is not exactly 60, it is 60 into 9.8. It can be something like 58.8 and all. Okay, but I make some approximations here. Now this 60 Newton is acting on the body downward, but we know that this 6 kg is in the state of rest here. So there must be some force balancing this 60 Newton. And you know that is nothing but the tension in the string. So that string experiences or develops a tension here. I'm showing that tension T here. And it's very clear that that T is also 60 Newton. You know why? Because this body is in equilibrium. It doesn't go up or down. It's a body in the state of rest. So it has to be some 60 Newton. Now it is said that the entire string is a light string. You know that if it is 60 Newton here, everywhere the tension has to be 60 because it is a light string. It is a massless string. So everywhere, here or here, no matter where, the tension is 60. So the same tension will be acting on the other end of the string also. So this T also has to be the same 60 Newton. This is 60. Now let us study the next body. This body has a mass of 4 kilogram, as it is said. And this 4 kg has its own weight. I'm showing the weight of that 4 kg again approximately. You know that 4 kg has a weight of some 40 Newton acting downward. Now look at the body carefully. Actually, this 4 kg experiences 40 Newton downwards as a part of its weight. And there is a string attached here. It is pulling the body upward at 60 Newton. But the body is in equilibrium. Even though 60 is bigger than 40, the body is in equilibrium. It is because this string is supporting it. So there must be a tension in that string. That tension is what I'm showing here. This is what is called T1 in our question. Now they ask you, what is that T1? It's very simple because totally 60 Newton is acting on this body upward. So the total downward force also must be equal to 60 40 is already there as a part of weight of the body. So T1 and this T1 plus this 40 must be equal to 60. That's a condition for equilibrium of this body. So I'm writing that condition now. T1 downward plus the 40, the weight of the body, that must be equal to 60. This gives you T1 as 60 minus 40, which is equal to 20 Newton. So 20 is the answer, approximate answer. Since I have taken G as 10, 20 is the answer, but you have to take actually 9.8. So when you make accurate calculations, it will be slightly less than 20. Okay, the exact answer will be 19 point something. And your answer is 19.6 Newton. Option is A. That's the first question. So this question was from laws of motion. The area is connected bodies. So there are certain key concepts we use here. The key ideas were weight of body and tension. Weight is nothing but a gravitational force acting on body, and tension is the restoring force acting in strings and all. And always remember, when string is very light, the tension at every point is the same also. So that was question number 1. Now, my friends, let me go to question number 2. Question 2, I'll read for you. A body B lies on a smooth horizontal table and another body A is placed on B. The coefficient of friction between A and B is mu. What acceleration given to B will cause slipping to occur between A and B? Unfortunately, a figure is not given in the question, but I have one figure for you to make it more clear. I'll give you a diagram corresponding to this question in the next page. Here is it. In this case, it is said that there is a body B. The mass of that body is not said. The body B is lying on a smooth horizontal table and another body A is placed on it. So I've made some modifications in the figure. You can consider this to be B. Okay, this platform is supposed to be B in the question, which can be easily moved. Okay, but the whole focus is on the next body, that is A. A is a body. Now the mass of this body is not exactly mentioned. Let us say it is some M. Now in the experiment, this platform will be given some acceleration forward. Somebody is pulling this platform forward. So this body, maybe this body M with mass M, you know, it is likely to accompany the platform. But if you are giving a larger acceleration, this M will fail to accompany the platform. Now the question is, if you are pulling this platform with a certain acceleration, there must be a slipping between these two bodies. These two bodies or surfaces must mutually slip. So what is the condition for that, or what is the acceleration required for that? That is the question. So let's do one thing. This is an accelerating frame. I suggest you to solve this question in non-inertial frame. Let us say some observer is standing in this platform, okay, and he will be a non-inertial observer, you know. In his observation, there are certain forces acting on this body. We will conduct a study on those forces reported by this observer. Okay, this observer will certainly see a pseudo force on the body since the frame is accelerating forward. You know that pseudo force is a non-inertial force reported by a non-inertial observer. So in his observation, he will see a force backward, and that force is called pseudo force. I'm showing that force here. This is the direction of that force. This is the force. And you know the expression for pseudo force is m into a, where m is a mass of body and a is the acceleration of frame. So this observer will report a force of ma backward. Now, even though ma is acting backward, the observer doesn't feel sometimes the body sliding. It is because there are forces to balance this ma. Usually, frictional forces will actually balance ma in usual sense, you know. So I'm just showing the direction of friction acting in this way. Let me say that friction is some Fs. Fs is the frictional force acting forward. Now the purpose of that Fs, static friction, remember, that is to balance ma. Okay, so these are the two forces at play in an accelerating frame. Now let us take two cases. If this ma, the pseudo force, is larger than Fs, you know, the body will begin to slide backward with respect to this observer. So this observer will feel that the body will accelerate backward if ma is greater than Fs. That is when the body slips. Now, if ma is less than Fs, certainly Fs will balance ma to keep the body in stable equilibrium with respect to the frame. What we want is slipping. The question is, what is A required so that the body starts slipping backward? So the condition is that this MA must be larger than FS for this body to slip backward with respect to frame. So that's what I'm writing, because they ask you what is the A for which the body starts slipping. So here is a condition. The condition is that MA must be larger than FS, the limiting friction. Fs, I mean the limiting friction. It is a maximum friction possible between the two surfaces. Now you'll remember Fs, the limiting friction, that is given by certain expression. I hope you remember Fs is nothing but mu into R, where mu is a coefficient of friction and R is a normal reaction. I'll just remind you of what is R here. The R I meant was this normal reaction. And you know, since it's a horizontal surface, R is nothing but a mg of this body. Therefore, Fs can be rewritten as mu into mg, that is the limiting friction. Now let me use this value of Fs here and rewrite the condition. I'm coming back to condition Ma. That must be larger than Fs, which is equal to mu into mg. They ask you what is A. So you can cancel this m here. A must be larger than mu into g, that is acceleration. If the acceleration of the frame is larger than this given value, the body will start slipping backward with respect to the moving accelerating frame. They ask you what is the minimum acceleration. A must be larger than this. So let me come to the minimum value. Okay, I can say minimum. At least it must be equal to mu into g. So that is your answer. Mu g. Acceleration of the frame must be greater than mu g. That's your option. You must go with option A in this question. Okay, friends. Let me go to the third question. That is also from the same lesson. A block of mass 10 kg is placed on a rough horizontal surface having a coefficient of friction 0.5. If a horizontal force of 100 Newton is acting on it, then the acceleration of the block will be. So a body is placed on a platform or some rough surface and a horizontal force is applied on it in order to drag it. Now it is supposed that the body is moving or sliding. Now they ask you what is the acceleration. And remember, the surface is rough. As the surface is rough, we must account for the friction also. I'm just showing a simple diagram corresponding to this question. Here is it. This is the body with a mass of 10 kilogram. And they say that there is an external force of 100 Newton applied forward. So this is the force that is applied forward. It's an external force. The purpose of applying this force is to give it an acceleration. Okay. When 100 is applied forward, certainly friction will try to resist it. And the 100 is supposed to be much greater than friction and all, but still there will be a friction. Now, since there is an indication that the body is likely to move, you must use a frictional force as Fk here. It is not static anymore because there is a hint that the body is likely to accelerate. So the friction can be kinetic in nature. So I'm using Fk. Now Fk is backward, and how to calculate Fk? You know, Fk is given by again that mu into R, where mu is a coefficient of kinetic friction and R is the normal reaction. As I just said earlier, R is nothing but mg of this body. If there is mg acting downward, you know that it is a normal reaction, capital R, that is balancing it since the surface is horizontal. So R can be written as mg also. So the Fk you can see here is equal to mu into mg. That's it. And in this question, you know, this Fk is given to be, sorry, mu is given to be 0.5 here. That is mentioned as 0.5, isn't it? Yeah, 0.5. And mg is 10 kg. 10 kg has mg of 100 Newton approximately. So that is 100. Okay, 0.5 into 100, that gives you some 50 Newton. That is the kinetic friction. So the Fk backward, you must expect is 50 Newton. You are applying a force of 100 Newton forward and there is a resistive force of 50 Newton acting backward. Even though there is a resistive force, you know that this body is likely to accelerate forward. The reason this 100 is much bigger than 50, so certainly the body will accelerate. Now the acceleration is what they are asking. Acceleration is 100 minus 50 because that's a net force acting on the body. Divided by mass of the body is 10 kg. Simple as that. It is going to be 50 by 10, which is equal to 5 meter per second squared. This is the approximate acceleration provided g is equal to 10 meter per second squared. So 5 meter per second squared is the acceleration of this block. So which is that? You must go with option B. That was my question 3. Friends, let me go to next question. Which one is that? Yes, question number 4. It is based on circular motion, I believe. Yes. What is the value of linear velocity if omega equal to 3I minus 4j plus k and r equal to 4I minus 6j plus 6k? So this is actually about a particle that is revolving in a circle. At some point of time, the particle has a velocity, angular velocity of 3I minus 4j plus k, and the position vector of that particle at that instant is given as 5I minus 6j plus 6k. If that is the case, then what is the linear velocity of the particle at that instant in vector form? That is it. So this requires certainly some equations, vector formulae with regards to linear velocity, angular velocity and all. I'll just explain what is given in the question. Here is a particle that is revolving in circle. I just assume that the particle has a linear velocity of some v in this direction. Maybe it is moving in circle, but at the moment the velocity of the particle is shown as vector v here. And where is a particle that is actually described in terms of a position vector drawn from the center? Let me say that is a position vector r. Now there is a third vector which is the angular velocity, which is omega. Okay, it's a revolving particle. The omega is a vector anyway. Now there is a relation between this omega, v and r, and you must always remember that. The vector formula for that must be remembered. You must recall that this vector v is always unconditionally, it is omega cross r. You must recall this equation. This is very essential. Omega cross r, not r cross omega. According to the sign conventions, you know, the conventions of vector product and all, it is omega cross r. Now it's just a matter of taking cross product of omega and r. Simple as that. Now let's see what is omega cross r. I use or depend on the matrix method, determinant method. Okay, I'll take I, first of all, I, j, k. This is I, j and k. Then what is omega cross r? Omega is 3I minus 4j, so minus 4, and plus 1k. 3 minus 4, 1. And for r it is 5 and minus 6, that comes again plus 6. Okay, this is it. So the determinant of this is going to be your answer. Okay, let me do it very carefully. Let me try to make no mistake. I into, first of all, it is minus 4 into 6, that is minus of 24. So this is minus of 24 minus minus of 6. So that's going to be plus 6. Okay, that's the first term. Minus j into next term. J into, it is 3 into 6, which is 18. So that 18 minus, okay, it is 5 into 1, which is 5. So that's j. Now comes the next term, which is k into, what is that? K into 3 into 6 is 18 minus 5. So this is it. Okay, let me simplify. Minus of 24 plus 6 is going to be minus of 18. So minus 18, that much I. Then I have some 13j, minus of 13j. Okay. Finally, I have 18 minus 5, which is 13. Is it? No, I made a mistake. K into 16 minus 5. Sorry, 18 minus 5, which is 13. So which one is that? Minus of 18, I, j, k. No, sorry, I made a mistake. It is minus of 18. Okay, this was wrong. Okay, let me correct this part. There was a mistake. My apologies for that. Plus k, that into, let me repeat that. Plus k into minus of 18 plus 20, exactly. Because it was this product, this minus this. Okay, I corrected it. So what is that then? Minus 18 plus 20 is going to be minus of, sorry, plus 2. Okay, it is plus 2k. So this is the value of the cross product of omega and r, which is equal to linear velocity. So minus 18 minus 13j plus 2k is your answer. Which one is that? It is option B. Okay, that was question number 4. Okay, let me go to question 5. A uniform rope of mass m and length L is fixed at its upper end vertically from a rigid support. Then the tension in the rope at distance L from the rigid support is The distance is measured from the rigid support. So possibly a rope is hanging on the ceiling and it's having a certain mass of capital M and length L also. You are required to find what's the tension at a particular point in the rope. Only rope is there, so it's not going to be very difficult at least. Okay, let me just show the rope. Presence of the rope is shown in the figure. Let me say capital M is the mass of the rope. And L is supposed to be the length of the rope also. Capital L is the length of rope. Now, you know this rope is having its own weight, but they ask you what's the tension at a particular point. Let me just point out that point. The point is supposed to be somewhere here. Okay, it's somewhere here. So they ask you what's the point, what's the tension at some point like this. Now they say that this point is at a distance of L below. So I'm just showing that distance here, and that distance is taken from the support also. From the ceiling, the distance is taken. So that distance is given to be L. Remember, the remaining distance below that point will be certainly L minus L. They ask you what's the tension at this point. The best way to find the tension at that point will be to divide the string at this level. Okay. In fact, the tension at this point is the force which supports the weight of the portion below this point. There is certain weight for that portion. It has an mg. That mg is being supported by the tension here. So to give you a clear view of what is that, I'll just give two parts of the string. Please believe that I have just for the moment cut the string into two. It is at that point reminding you that this length is L. This length continues to be L minus L. Okay, it has its own weight also downward. Let me first of all show what's the weight of that portion. Okay, that piece has its own weight. Now what is the weight of that portion? That is governed by the total mass of the string. It is given that in L, over L length, you know, there is a mass of capital M. So over a unit length, it will be M by L then. M by L is the mass per unit length of the string. We need to find what is the mass of this length. So it is mass per unit length into that. So this into L minus L, that will be the mass of that piece. That is what I'm writing. So the mass of this piece is M by L, that into L minus small l. That's the mass of that. So this portion is having its own weight also. I'm showing the weight now. It is mg of this part, or M by L into L minus L. That into G is the weight of that part. So the fact is that this piece is having its own weight. But even though this has its own weight, some other force is balancing it. That is why this part is in equilibrium. And which is that force? It is a force of tension here. The molecular force is actually balancing it. So just showing that the tension is acting upward. This is the tension, this T. Now that T, the molecular forces, that is the force which balances this M by L into L minus Lg. So this T must be equal to this. That's the idea. So I come to the answer. T is equal to, tension at that point is equal to M by L into L minus L, that into G. This is the tension at that point. So mg into L minus L by L, it looks like, which is the option? Yeah, which one? It is this. You can go with option B. Okay, please consider a bracket here. All right. Option is B. That was question number 5. Moving on to question 6. Again, a question about a body in accelerating frame. A pendulum with a bob of mass 2 kg is hanging from ceiling of a trolley as shown in the figure. The trolley is uniformly accelerating with acceleration of A, and you can take G as 10 meter per second square also. Now in the figure it is given that this body is actually, the whole string is inclined to a certain angle which is clearly given here as 37 degree. Hopefully that 37 is a convenient angle. Okay, we'll use that angle finally. Now if the angle of inclination of this string with respect to vertical is 37 degree, then what is the acceleration of the frame? That is it. The trolley is uniformly accelerating with an acceleration A, then what is A is the question. So here also you are seeing a body in accelerating frame. I advise you to solve this question as a non-inertial observer standing inside this trolley. I'll suggest that. Just for a moment you assume that the whole thing is being studied by some observer like this. And this guy is looking at this body and reporting all the forces. Now whatever steps I'm writing here will be the steps reported by this observer, remember. In his observation, this body experiences many forces. He sees all the real forces acting on the body, like mg, tension, etc. So let me show all the real forces first. Let me begin with mg first. Okay, certainly this body experiences a weight, and that weight is supposed to be some mg, and that is acting downward. And this observer will also see a tension T in this direction, and that is an inclined force. So to make it convenient, let us resolve it, because we assume that the string is making right now certain angle theta. Even though it is given as 37, I can use it later. Let me use theta as the angle made by the string. Then the T can be resolved into two components. One is a vertical component, that is upward, and this angle is also theta, remember. So the component vertically acting will be T cos theta. The same T has a component in this direction also. Okay, this is it. What happened here? Okay, this is theta. Okay, this one is T sin theta also. That's a horizontal force acting as a part of the component of tension. So these are the two components of tension, T sin theta and T cos theta. Now see, T cos theta balances mg. What does T sin theta balance? Yes, in his observation, there is one more force to be reported on the body, and that is pseudo force. Because this frame is supposed to be accelerating forward. It is supposed to be having an acceleration A. Then this observer must report a pseudo force on this body in the backward direction. And you know that the magnitude of pseudo force is ma, where A is the acceleration of frame. Now, in his observation, this body is in the state of rest. So there are certain forces which balance together. Certainly, T sin theta balances ma, and T cos theta, this vertical force, that will balance mg. These are the two expressions we are writing based on his observations. So here is the equation, set of equations. Yes, T sin theta equal to ma is equation number 1. And T cos theta is the force that balances the weight of the body. That is equation number 2 also. These are the two forces. Now, to get a relation between theta and g, I shall divide 1 by 2. Okay, I'll be dividing equation 1 with 2. So T sin theta by T cos theta on the left side will give you tan theta. So tan theta is equal to, on the right side, mass is cancelled. What remains is A divided by G. So tan theta is A by G. This is actually the equation for the angle of inclination. Better, you must remember this equation by heart. ഈ ടൈപ്പിൽ ഈക്വേഷൻസ് ഒക്കെ പഠിച്ചു വെക്കുക നല്ലത്. ഇത്തരം ക്വസ്റ്റ്യൻ വന്നാൽ ഈ ടി സൈൻ തീറ്റ, ടി കോസ് തീറ്റ അതൊക്കെ സ്പ്ലിറ്റ് ചെയ്തിട്ട് അത് കാൽക്കുലേറ്റ് ചെയ്യാനുള്ള സമയം കളയരുത്. ബെറ്റർ you keep these equations of similar type, you must have in your fingertips. Okay, now tan theta is A by G. They ask you what is A. And a value angle, here is the equation for A. A is equal to G tan theta. And G can be taken as 10 in this question, and it is 37 degree. So G tan 37. Now tan 37 value you must know. Tan 37 value is 3 by 4 in fraction, or I can say it is 0.75 in decimal, tan 37. So the final answer comes 10 into 0.75, and the answer is 7.5, that much meter per second squared. That is the acceleration of the given frame. Since the angle of inclination is 37 degree, the acceleration must be 7.5. So my friends, I would ask you to get this equation by heart. There are many equations like these you may require, okay, in solving questions. That was question 6. Okay, let me move on to question 7. We must be more careful here because there are many statements given. We have to check the validity of each and every statement here. A metal sphere is hung by a string fixed to wall. The forces acting on the sphere are as shown in the figure. Which of the following statements is correct? That's it. So we have actually a huge sphere hanging on a string. You can see that the string is inclined, and partly this sphere is being supported by the wall as well. That is why the string is inclined. Now the whole question is about 3 major forces that are shown on this body, T, R and W. T plus R plus W is equal to 0. So there are many arguments made in the options. Let us take them one by one. Let me first of all begin with all the forces they have shown here. First of all, a major force they have shown in the figure is T. That's a force acting on this sphere. Now you know there is a W. The weight of this body certainly is acting down. That W is shown as a force downward in the figure. Now you know this body, the whole body is actually being supported by this wall also. There is an action given by the ball on the wall. So there must be some reaction, same amount of reaction will be there exerted by the wall on the ball also. So that reaction is the next force. Actually, it is shown in the figure as a force here. See, this is the way it is shown. Okay, actually, I have to show it like this. But anyway, the force, the point of application of force is here. So I'm just showing that. This is the force of reaction. That's the reaction offered by the wall, remember. This is R. Now, the first claim is this. Actually, the R can be shown here also. If it is difficult for you, you can assume that R is acting here. Because every force on a large body will be acting on the center of mass. So there is nothing wrong in showing it here. It's okay. ഞാൻ ആ പറഞ്ഞ ഫോഴ്സ് ഈ തട്ടുന്നിടത്ത് കാരണം ഈ ബോഡികൾ തമ്മിലുള്ള ആക്ഷൻ റിയാക്ഷൻ പേര് ആ കോൺടാക്ട് ചെയ്യുന്ന പോയിന്റിലാണല്ലോ ആക്ട് ചെയ്യുക. അതുകൊണ്ട് അവിടെ കാണിച്ചെന്ന് മാത്രമേ ഉള്ളൂ. All right, this is the reaction, direction of reaction. So these are three forces acting on this body. Now the first statement, let us see. R plus T plus W equal to 0. See, this body is in equilibrium. There are three major forces acting on it, W, R, and T. Now, since the body has no acceleration, or it is in equilibrium, the net force acting on the body must be 0. Now, what's the net force? Net force is nothing but the vector sum of all these forces. So, saying that vector R, vector T plus vector W equal to 0 is absolutely correct because the net force acting on the body is 0. So, part or statement A is correct. I'm just saying that A is a correct statement. Okay. Let's see the next statement, which is T squared equal to R squared plus W squared. Let's see if that is correct. To explain that, I'll try to resolve this tension at least into two components. That will make it easy. Okay, here T can be considered to be a combination of two components. One is some T cos theta or sin theta. Let me take this as theta. Can you see that? Okay, yeah. This is theta. So T will have a component of T cos theta in the upward direction. Now T will have a component in this direction also. Okay, this is the component I'm showing. So this T is actually T sin theta. That is a horizontal force. Now the normal reaction is acting in this direction. Okay, now I'll make it easy for you. This normal reaction, even though it is acting there, as I did earlier, I'll show the normal reaction, the point of application of normal reaction to be here. So these are the major forces. Now the only difference is that T is being resolved into T cos theta and T sin theta. Now look at the vertical and the horizontal equilibrium of the body. T sin theta is a force that balances R. So that is one equation I can write here. Okay, T sin theta is equal to capital R is true. That is equation number 1 I have. Secondly, this T cos theta is a force that balances W. So T cos theta is equal to W. That is also true. That is equation number 2. Now, if you square and add these two expressions, I'm saying this square plus the next equation square, that gives you a simple result because it is going to be T squared sin squared theta plus T squared cos squared theta on the left side. That is equal to, on the other side, it is R squared plus W squared. So when you square and add these two expressions, you will have this result. Now T squared is common here, so T squared into sin squared theta plus cos squared theta, you know that is equal to 1. So T squared into cos squared theta, sin squared theta plus cos squared theta equal to R squared plus W squared is the result. Now you know that sin squared theta plus cos squared theta is 1. Therefore, T squared is equal to R squared plus W squared is a correct result. They say that in this figure, T squared plus R squared is equal to W squared. So you must say that that's also a correct statement. So B is also correct. What about C? T equal to R plus W. The magnitude of tension is equal to sum of the W and R. That is not true because only this is true. T squared is R squared plus W squared is okay. But that doesn't mean that T is equal to R plus W. That is totally wrong. Okay, if you add all the forces like scalars, you won't get 0 for a stable, for a body in equilibrium. So that is wrong, but this is right. Okay, so I must say this is wrong. This one is a wrong statement, all right. Now what about D? R equal to W tan theta. W tan theta, let's try that. W tan theta is R. I will suggest a few other calculations with the equations 1 and 2. Let's try and divide this, okay? If you divide equations 1 with 2, you'll have sin theta by cos theta as tan theta on the left side, equal to R divided by W. Now, when you cross multiply this, you'll see that R is equal to W tan theta. That also appears to be correct. So, R equal to W tan theta is also a correct statement. So, this one is also correct. D is also correct. So, I could see that A, B as well as D, these are the correct statements. So, you can go with your option C. That was it. So, that was 7. Let me move on to question 8. A uniform chain of length 2L. I hope on your monitor this is visible. Otherwise, I'll read it for you because the letters are too small. I hope you can handle. All right. A uniform chain of length 2L is hanging in equilibrium position. If end B is given a slightly downward displacement, the imbalance causes the acceleration. Here the pulley is very small and smooth and string is inextensible. The acceleration of the end B when it has been displaced by distance x is. So please understand what they are saying in the question. In the beginning at least, as per the figure, this A and B are at the same level. So there is no chance of any acceleration. Now in order to initiate acceleration, they are trying to pull this B slightly down. So when you pull B slightly down, certainly the end A will slightly rise up. That will cause an imbalance because at one side the weight will be larger than on the other side. Then the system will start accelerating. Maybe this is accelerating with a variable acceleration and all. So finding an acceleration, equation for acceleration in terms of time and all, this can be very difficult. They don't ask you that. They just ask you, what is the instantaneous acceleration of the system when x distance has been actually pulled down? That's it. ഒരു given instantly acceleration എന്തെന്ന് മാത്രമേ ഉള്ളൂ. ഓരോ സമയത്ത് acceleration അല്ല, അല്ലെങ്കിൽ acceleration ടൈമായിട്ട് ബന്ധപ്പെട്ട് equation ചോദിച്ചിട്ടില്ല. They are just asking you, what is the acceleration at a given instant? And at which instant? At an instant where the end B is pulled by a distance of x. So, there is an imbalance in the figure, at least not in the figure given in the question, but as the question proceeds, there can be some imbalance like this. Look at the figure. I have shown that end B has been pulled down. Remember, this end B, what happens when you pull end B, you must understand. When you pull the end B through a distance x, then certainly this end A will rise through the same distance x. Now this will be at the new level. And look at the level difference now. There will be a level difference of 2x then. Because one side x താഴേക്ക് വലിച്ചാൽ അപ്പുറത്തെ സൈഡ് x മുകളിലേക്ക് പോകും. അപ്പോൾ ഈ രണ്ട് എൻഡുകൾ തമ്മിലുള്ള ഡിസ്റ്റൻസ് ഡിഫറൻസ് 2x ഉണ്ടാവും. അതുകൊണ്ട് തന്നെ ഈ ഫിഗറിൽ ഞാൻ ഉദ്ദേശിച്ച ഈ ഗ്യാപ്പ് ഓൾവേസ് റിമെമ്പർ ഇൻ ദിസ് ക്വസ്റ്റ്യൻ ഇറ്റ് ഇസ് 2x. അപ്പോൾ ആ 2x ലെങ്ത്തിന്റെ വ്യത്യാസമുണ്ട്. അപ്പോൾ പിന്നെ ഇത്രയും ഭാഗം എക്സ്ട്രാ മാസായി. ഈ മാസിന്റെ അഡീഷണൽ മാസിന്റെ വെയിറ്റ് ഡിഫറൻസ് ആണ് ആക്ച്വലി ഈ സിസ്റ്റം ആക്സിലേറ്റ് ചെയ്യാനുള്ള കാരണം. Now they ask you what is that acceleration. Now to find what is that acceleration, let me go back to basics again. I remind you of acceleration of two-body system. ഇതൊക്കെ ഓർമ്മയിൽ വെച്ചാൽ നല്ലതാണ്. I'll just remind you of this system first of all. Later we'll see what happens here. Okay, I'll come to that. Here, look at this. If this body has a mass of some m1 and on the other side if it is m2, acceleration of system, of course, it occurs like this. This will go down with an acceleration a and m1 will rise up at an acceleration a. That's a common acceleration. That acceleration is given by a straight equation. You must get this equation by heart. It is m2 minus m1 into g divided by m1 plus m2. That's a standard equation for acceleration of a two-body system. If m1 is mass on one side, m2 is that on the other side. This is it. Now let us modify this equation for the purpose of this question. Look at this term very carefully. What is this m2 minus m1? m2 minus m1 is the mass difference on the two sides. So m2 minus m1 g is basically the weight difference. So m2 minus m1 is mass difference. Let us see what is mass difference here. When you look at our question, you'll see that the mass difference is actually caused by this extra piece. That's a mass difference. So that extra piece, this weight of or mass of this extra piece, that is appearing as m2 minus m1 in your term. So let us find that mass difference. Let's see what is the mass of this portion. Now I told you that this portion has actually a length. I'll just show the length of that piece, that is 2x, not x, because one end is pulled down through a distance x, so the other end rises up by the same distance x, so the distance difference between the ends will be 2x. Now let's see what's the weight of that portion. I'm just finding what is the mass of this portion. Okay, 2x. They say that the total length of the chain, starting from this point up to this, total length, that is given to be 2L. 2L length M mass. Let us say M is the mass of the whole string. This string in the total mass is capital M. Capital M 2L mass. Mass per unit length is going to be M by 2L. This portion of mass. Because that portion is having a length of 2x. If mass per unit length is M by 2L, then mass over length 2x is this into 2x. That's the mass of that portion. So that into 2x is the mass of that portion. And this is, okay, this quantity is what is appearing as M2 minus M1 in the previous expression. So this M2 minus M1 is appearing as M by 2L into 2x. Okay, so let me write the equation for acceleration now. It is M2 minus M1 into G, which means M by 2L into 2x, that into G. Okay, this is your M2 minus M1 G. Now I have written this term. The term that represents the term here is M by 2L into xg by total mass. Total mass means the total mass of the system or string. And I told you that it is capital M. Yes, it's over. This M and M gone, 2 gone. Finally, what you get is x by L times g. That is the acceleration of the system at the given instant in the question. When x is a distance through which one end is pulled, that moment this will be the acceleration. This is the instantaneous acceleration. Remember, 1 microsecond later, it will be a different acceleration because the length difference is growing. So the acceleration keeps on increasing also. Anyway, in our question, the answer is x by Lg. So please go with option A. That was question 8. Okay, moving on to the next one. 9. A chain is lying on a rough table with a fraction of 1 by n of its length hanging down from the edge of a table. If it is just at the point of sliding down from the table, then the coefficient of friction between the table and the chain is. So it's a long chain. Part of the chain is resting on the table and the remaining part is hanging vertically. Now it is said that the chain is at the brim of slipping. In that case, what is the coefficient of friction? That's what they ask. So this is a full chain. I have given you a figure here indicating that the full chain is this. Now this chain, full chain has a total mass. Up to this point, the chain is extending from this point to this point. And the total mass of the chain is supposed to be some m. Now they say that a part of the chain, 1 by n of the length of the chain, means m by n mass is hanging vertically. And the remaining mass is still staying on the table. Now what's the remaining mass? If m is the total mass of the chain and m by n is hanging, then the remaining mass is going to be m minus m by n. That's the way we consider masses. Okay, so assuming that m is the total mass, I'll assume that m is the total mass of the chain. Then as per the statement, m by n mass is hanging. Okay, that is hanging down. Now this m by n mass, okay, that is m by n. And the remaining mass is still here, reminding you that it is m minus m by n. So that's the way I have described masses. Okay, now let us see the forces acting on the system. This m by n mass, that will cause a weight. This part has its own weight. And that weight is m by n into g. So I'm showing that the weight of the hanging part, I'm showing here, that is supposed to be m divided by n into g. Okay, I hope my letters are not missing. Is it all right? Yeah, it's appearing. Thank you. M by n into g, that is acting vertically down. Now this is the force trying to drag the chain. Now even though there is an mg like this, m by n g like this, there must be some force trying to resist it. Which is that? You know that it is nothing but friction because the whole chain is lying on a rough table. So the friction will be holding it back. So there will be static friction in this way, and that is Fs. Okay, static friction. I'm showing here that Fs is acting in the backward direction. That is Fs. Now, when will the chain slip? Remember, if this m by n into g is greater than Fs, the chain will slip. But the chain doesn't, if the chain doesn't slip, it means that this m by n g is not sufficient to break friction. In other words, the m by n g in the figure must be less than or equal to Fs for the chain not to slip. Now, less than or equal to, എന്നത് വേണമെങ്കിൽ equal to എന്ന് പറയാം, because they are asking you about minimum and all. അതുകൊണ്ട് at the brim ഒക്കെ ആയതുകൊണ്ട് nothing wrong in saying that m by n g is just being balanced by the static friction Fs. Even that is enough. Now, let's put values. Fs, limiting friction. You know that limiting friction is always mu into r. Let me bring the value for Fs. It's always mu into r, where mu is the coefficient of friction. Now, what is r here? R is a normal reaction, reminding you that this is the mass that is resting on the table. So the table is supporting that by exerting a reaction upward. Now, what is that reaction equal to? That reaction is equal to weight of that chain, weight of that part of the chain. So weight of that part of the chain is downward, which is being balanced by the normal reaction upward. So normal reaction R is nothing but mg of the part of the chain lying on the table, which means m minus m by n into g. So one can conclude that the normal reaction R acting here is m minus m by n that into g. That's the normal reaction acting on the chain. Okay, now let me put that value of R here. I'll rewrite Fs. It is mu into m minus m by n that into g. Okay, that is Fs. Now going back to the condition, you know that m by n g must be equal to Fs. So here is my final step. M by n that into g is equal to, it is Fs, which is mu into m minus m by n that into g. Now there are several terms I can cancel. M is appearing common, I'll cancel it. G is also common, I'm going to cancel it. What remains can be 1 by n is equal to mu into 1 minus 1 by n. That is it. Now let me simplify this. 1 minus 1 by n can be written as mu into n minus 1 divided by n, and on the other side also there is 1 by n. So n and n cancelled. Finally, I get mu as 1 by n minus 1. That is the answer. So the result is mu equal to 1 by n minus 1. Okay, so what is the option? Let me see which one is that. Exactly. The answer is B. So B is the right option. Okay, friends, let me go to the next question. 10. Which is again a question based on accelerating frame. A block of mass m is in contact with the cart C as shown in the figure. The coefficient of static friction between the block and the cart is mu. The acceleration alpha of the cart that will prevent the block from falling down will be, or it satisfies which condition? That is it. Here also you can see an accelerating frame. And because of the effect of acceleration, the body of mass m manages to stick on the frame, stick on the wall of the frame. So what is the minimum acceleration required for that? That is it. They ask you, what is the value for this alpha or A? I'll be calling it A. They ask you, what is the value of that A? So that this doesn't fall down. Even though there is an mg for this, it doesn't fall down because there is some other force which is trying to balance mg. Let us try to see what are the forces at play here. Here, let's again, since it's an accelerating frame, I will again suggest you to consider yourself as an observer inside this frame. Please consider yourself as this, and you are reporting the forces acting on this body. And remember, since the frame is accelerating forward, you naturally are an accelerating observer. Since you're an accelerating observer, you must see some pseudo forces also on the body. But let us report first of all the real forces. Now, in his observation, yes, this body experiences something called a weight. There is a weight mg acting downward. That is a weight of the body. In fact, it is downward. Okay. Now the other force he must report is pseudo force, because he is a non-inertial observer. Since the system is having an acceleration A, this body will be experiencing some ma backward in his observation. Okay. So I'm showing that the ma pseudo force is shown here. That is pseudo force ma. Now see, in his observation, this body is not moving left or right. It is because there is some other force trying to balance this MA, and this is nothing but normal reaction, because this wall is exerting a reaction this direction. That is what balances this MA. So in his observation, there is one more force in this direction, which is the normal reaction, that is R acting towards the right. Okay, now let's see which is that force which prevents mg. Because even though mg is acting there, the question claims that the body doesn't slip down. Why? Because mg is being balanced by some vertical force. So here, mg is, okay, I think there is some low battery issue. Okay, let me finish this question. Yes, mg is acting down, and mg will be balanced by friction here. Friction is the only force that is trying to balance mg. There is no other force. So this is going to be mg. That mg is acting upward. Sorry, my mistake. mg is acting downward. The frictional force Fs is acting upward. So these are forces acting in various directions. Now we are studying the equilibrium of this body. Let us see what's the condition that this body doesn't slip. See, when does the body slip? Let's understand. First of all, this mg is acting downward and Fs is acting upward. If mg is bigger than Fs, certainly the body will slip down. If mg is larger than Fs, the body will slip down. What we need is the condition for not slipping. So body doesn't slip if mg is less than Fs or equal to Fs. So I'm writing the condition for not slipping. Here is it. mg less than or equal to Fs. That is a condition for no slipping. Now let's write what is Fs. You know that Fs is always mu into R. So it is mu into capital R, where R is the normal reaction. And what is the normal reaction here? I told you that this R and MA are equal. Why equal? Because in his observation, this body is in the state of rest. So R must balance actually MA. Therefore, R can be rewritten as MA. So mg less than or equal to mu into MA, and this M and M cancel out. They ask you what is A. So rearranging, you'll see that A must be greater than or equal to what? G divided by mu. That is it. So acceleration of the frame, if it is greater than or equal to at least G by mu, you can manage the body to keep stationary on the surface or with respect to surface. They ask you what is the minimum acceleration or condition for that. The answer is this A. In my case, it is A. Okay, that's alpha in the question, but I'm using A. That A must be greater than or equal to G by mu. Isn't that the result I got? Yes, this one is my result, G by mu. And you must go with option C. C is your answer. Okay, my friends, please wait. I think the battery is running low. I'll just fix it. Don't go away. Please wait. ആ ലാപ്പിന്റെ ബാറ്ററി ഡൗൺ ആവുണ്ടല്ലോ. Okay, friends, I called my technician and he'll come and fix it. Please wait. Only a matter of minutes. No, label. Okay. Hello. I hope really. Okay, friends, am I audible? Yeah, I think everything is all right. Okay, that was question number 10. I think I can go to 11 now. Let me wait for your comments now. Let me see if there is still any technical issue continuing. My friends, please tell me if everything is okay. Can I continue with question number 11? Anyone just give me yes. Yes, I think it's okay. Thank you. Okay. Yeah, I'm going to question number 11. A man is standing on a rough horizontal disk rotating with a constant angular velocity of 5 radian per second. At what distance from the center should he stand so that he does not slip on the disk? So you must imagine that there's a rotating table or disk which is free to rotate about a central axis, and some person or a body is placed on the table. Now, if the angular velocity of the whole disk is exceeding certain limit, the body is likely to slip away. So the question is, what is the distance at which the body must be kept so that it doesn't slip? Again, this is a non-inertial frame. I would like to solve it in a non-inertial frame. So here is the full situation. This is the disk, and we'll assume that this disk is actually rotating with a certain angular velocity of omega, and it is said that some person is standing on the disk and all. I have just shown a body only. Okay, we'll discuss the physics of the question. So I just keep a body on this disk and believe that this body is also rotating along with the disk. But you know, if the angular velocity is larger than certain limit, this body is likely to fly away. Now the question is, what is the maximum distance at which this can be kept? Let's do again one thing. Let us find the forces acting on the bodies first in non-inertial frame. Again, you must imagine that you are actually acting as some observer, okay, standing somewhere in the rotating frame, and he is reporting certain forces. Okay, I'm just showing that this body at present is at a distance of r away. Now, m is supposed to be mass of this body. You know, in the observation of a non-inertial observer, this body will experience something called centrifugal force. And centrifugal force is also a pseudo force, you know it. And the equation for centrifugal force is mr omega squared, or mv squared by r. But I'm using omega here. Okay, mr omega squared is a centrifugal force. So this centrifugal force is likely to push the body away radially. Okay, in the observer's observation, in the non-inertial observation. So there must be some other force to balance mr omega squared. ഈ കാണുന്ന mr omega squared body റേഡിയലി പുറത്തേക്ക് വലിക്കുമ്പോൾ അതിനെ ബാലൻസ് ചെയ്യുന്ന ഫോഴ്സ് ഉണ്ടെങ്കിൽ മാത്രമേ ബോഡിക്ക് അവിടെ നിൽക്കാൻ പറ്റൂ ഇൻ ദി നോൺ ഇനേർഷ്യൽ ഒബ്സർവേഴ്സ് ഒബ്സർവേഷൻ. അപ്പോൾ ആ നിലയ്ക്ക് ഈ കാണുന്ന ഫോഴ്സിനെ ബാലൻസ് ചെയ്യാൻ ഫോഴ്സ് ഉണ്ടാവും. ആ ഫോഴ്സ് ഫ്രിക്ഷൻ ആണ്. ഐ എം ഷോയിങ് ദാറ്റ് ഫ്രിക്ഷൻ ഹിയർ. യെസ്, the body has a tendency to move outward in the non-inertial frame. So there will be some Fs trying to prevent it. So that is static friction. Until the body slips, you can say F is static. Now let's see when does the body slip. Body slip ആവുള്ള കണ്ടീഷൻ പറയാം. ഇതൊക്കെ തിരിയുന്നുണ്ടെങ്കിലും ഈ mr omega squared ഈ Fs-നേക്കാൾ ലാർജർ ആയാൽ ഫ്രിക്ഷന് ബോഡിയെ പിടിച്ചു നിർത്താൻ പറ്റില്ല. അപ്പോൾ സെൻട്രിഫ്യൂഗൽ ഫോഴ്സിന്റെ എഫക്റ്റ് കൊണ്ട് ബോഡി സ്ലിപ്പ് ആവും. അതല്ല mr omega squared വാല്യൂ Fs-നേക്കാൾ ലെസ് ആണ്, അല്ലെങ്കിൽ ഈക്വൽ വരെയൊക്കെ ആണെങ്കിൽ ഈ ബോഡിക്ക് സ്റ്റേബിൾ ആയിട്ട് കണ്ടിന്യൂ ചെയ്യാൻ പറ്റും. So let me write the condition for the equilibrium of the body in the non-inertial frame. Here is it. mr omega squared, that must be less than or equal to. Okay, it should be never larger. It must be less than or even equal to that Fs. So this is it. Now let us simplify this. Now coming to Fs, reminding you that Fs is the maximum value of static friction, and you know that Fs is nothing but mu into r. So that's mu into r, where r is the normal reaction. The r I meant here is normal reaction. And since it is a horizontal table, normal reaction is simply mg. So Fs is equal to mg. Okay, let me rewrite the condition now. mr omega squared must be less than or equal to mu into mg. That's a condition that the body doesn't slip. Now, I can certainly cancel m here. The question is about what is r. So here is my equation for r. R less than or equal to mu g divided by omega squared as per the question. Now finally, I put values. R less than or equal to mu. In the question, mu is said to be 0.5. So that is 0.5 that into G is okay taken as 10, divided by omega squared. In the question they say that omega is 5. 5 radian per second is omega. So it is going to be 5 squared or 25. So R must be less than or equal to, it is 5 divided by 25. 5 by 25 is actually 1 by 5. 1 by 5 means 0.2. So finally this is the answer. R must be less than or equal to 0.2 meter. That is it. So if you're keeping the body beyond that, certainly the body will slip. So R less than or equal to 0.2 meter, which is that? Yes, this one. You go with option A. That was it. That is question number 11. Okay, let me go to the next question, which is question number 12. Okay, looks like it is coming from the next chapter. It is work energy power, because they ask you to calculate the work done by certain force in shifting an object from one point to another point. I'm reading it for you. Question number 12. Shall I continue? Okay, yeah. Question number 12. A body of mass m is placed from point A 312 to point B 433 under the effect of a force F is equal to 3I plus 2J plus 4K. Then calculate the work done by the force. Okay, simply displacing an object from one point to another point, and it is being displaced by a force. So it looks like this. Just a simple diagram for the corresponding question. This could be the body A, and it is being transferred from point A to point B by a force of capital F. So F is a force acting in some way, and the displacement is said to be some from A to B. Now the question is, what is the work done by the force to displace the body from A to B? You know that work W is equal to Fs cos theta, or in pure vector form it is F dot R, where F is the force vector and R is the displacement vector. Now, what is a displacement vector? Let me try to show what is displacement vector here. The body was initially at A and later it is transferred to B. So when it was at A, this was the position vector. I'm going to call it some RA. Okay, this is the initial position vector RA of the object. Now finally, after displacing it, it reaches a point B. So this is the position vector of the same object later. So let me call it RB. Now body is being shifted from A to B. So this is A and this is B. So this must be vector R. That is a displacement of body. So that is R. So you can find what is R using RB and RA, because you know that in the triangle, this is one vector, this is a second vector, this is a third vector. You know that this RB is equal to R plus RA according to vector rules. So I can just remind you of the vector algebra. This RB is equal to RA plus vector R as per triangular law. So if you want R, then it is simple as RB minus RA. That's how we find the displacement vector, RB minus RA. Okay, what is RB now? That's A and B coordinates. A and the point coordinate are 3, 1 and 2. RA is 3I plus J plus 2K. B coordinate, that's given as a 4, 3, 3. So this is 4, 3 and 3. That is it. Now RB minus RA I am writing. Say R is equal to RB first of all. RB is 4I plus 3J plus 3K. That is RB. This minus now RA. RA is going to be 3I plus 1J plus 2K. This is RA also. Now let me get what is R here. Okay, I'm trying to get what is R. It is 4I minus 3I is going to be I here, plus 3 minus 1 is okay, 2J. Then 3 minus 2 is okay, 1K. So this is the displacement vector. I plus 2J plus 1K. Okay, now let me come to the calculation of force then. It is F dot R. F is said to be 3I plus 2J plus 4K. That is F that dot. Okay, that into I plus 2J. Okay, I plus 2J plus 1K. That is R vector. Finding dot product is so easy. It is just 3 into 1, which is 3. So that is 3 plus 2 into 2, which is 4 plus 4. 4 plus 4, 8 plus 3. The answer is 11. And it is work. So 11 joule is the answer. So 11 joule is the work done in shifting the body from A to B. Is it not? Yes, correct. It is B. Option is B. Okay, that was 12. Moving on to question number 13. 4 joules of work is required to stretch a spring through 10 centimeters beyond its unstretched length. The extra work required to stretch it through additional distance of 10 centimeters shall be. You have already stretched it through distance of 10 centimeters. Now you want to additionally stretch it through another 10 centimeters, and the question is what is the work required. Okay, reminding you of work done in stretching a spring. Believe that in my 3 figures, this is the natural length. In the first case, I have stretched it through one certain length, and second case, I have stretched the same spring through a larger length also. Please believe that in the first case, I have stretched it through a distance of x1. So let me say that in the first case, the length of stretch is x1. And you know that the work required for that is W equal to half K into x1 squared. That's the work required to stretch a spring. Okay, in the second case, I assume that it is elongated through a larger distance. See, that's original length. രണ്ടാമത്തെ കേസിൽ ഇതാണ് stretch. Okay, total stretch ആണത്. So, the original length adana. Don't forget that this one is original length. Okay. Original length I'm actually stretching it through a distance of x2. So to elongate is through a distance x2, the W2, let me call it W2, the work required is actually half into K into x2 squared. Up x1 വലിക്കാൻ half K x1 squared. x2 വലിച്ചു നീട്ടാൻ half K x2 squared. എങ്കിൽ ഒരു ഗിവൺ ലെങ്ത് മറ്റൊരു ഗിവൺ ലെങ്ത്തിലേക്ക് എത്തിക്കാൻ എത്ര വർക്ക് എന്ന് ചോദിച്ചാൽ ഈ വർക്കിന്റെ ഡിഫറൻസ് പറഞ്ഞാൽ മതി. So the work required to elongate it from x1 to x2, that's a difference in work. So W required for our experiment, you know, that is going to be half K x2 squared minus half K into x1 squared. Basically, this is the work required to stretch it from x1 to x2. I'll make it simple by taking common factors. It is half K into x2 squared minus x1 squared. This is the equation we are going to use to solve this. Now let us go back to question and see what are the data given. Number 1, half into K into. Let's see first of all what is x2 and x1. In the question it is said that the spring is already stretched by a distance of 10 centimeter. So x1 is 10 centimeter in the question. Let me use that value. That is 10. What is x2? x2 is totally it is x2 is 20 because they say that 10 centimeter length വലിച്ചിട്ട് പിന്നെയും 10 എന്നല്ലേ പറഞ്ഞത്. പിന്നെയും 10 എന്ന് പറയുമ്പോൾ ഈ കാണുന്ന ഡിസ്റ്റൻസ് 10 10 കൂടി 20 ആയി. അതുകൊണ്ട് total stretch in the second case is 20 centimeter because with respect to natural position or length, you know, the elongation is 20. അതുകൊണ്ട് x2 എന്ന് പറഞ്ഞാൽ 10 എന്ന് അവർ പറയും, പക്ഷേ അത് equilibrium position എടുക്കേണ്ടതാണല്ലോ. അതുകൊണ്ട് 20. So see, x1 is 10, x2 is 20. So this is some 20 squared minus 10 squared. This is it. നിങ്ങളുടെ ആൻസർ ഇതിലുണ്ട്. But the issue is that what is the value of K they have not given? അത് വേണമെങ്കിൽ നമുക്ക് അവർ പറഞ്ഞ ഫസ്റ്റ് സ്റ്റേറ്റ്മെന്റ് ഉണ്ടാക്കാം. Because they say that the work required to stretch it through 10 centimeters 4 joules. So let me write that equation and find what is K. Half K into 10 squared because 10 is supposed to be the elongation in the first case. അത് 4 ജൂളാന്ന് അവർ പറയുന്നുണ്ട്. ഓക്കെ, അത് വെച്ച് നിങ്ങൾക്ക് വേണമെങ്കിൽ ഈ കെയുടെ വാല്യൂ ഉണ്ടാക്കാവുന്നതാണ്. ഇറ്റ് ഈസ് 8 divided by 100 or 8 by some 10 squared. So I'll be using that here. So finally here comes my answer. Half into 8 divided by 100 is K. That into 20 squared minus 10 squared means 400 minus 100, which is equal to 300. Okay, so 0 is gone. 24 divided by 2, which is going to be 12 joules. So the answer is 12. 12 joule is the work required to stretch it from 10 to 20 or additional 10 centimeter. So you must go with option C. That's it. That was question number 13. Okay. Question number 14. A body of mass M tied to a string is lowered at a constant acceleration of g by 4 through a vertical distance h. The work done by the string will be. You have a body attached to a string and you are slowly lowering it in such a way that the body is given an acceleration of g by 4. The body is allowed an acceleration of g by 4. So even though the string is holding it up, you are allowing the body to go down. They ask you, what is the work done by the string? Okay, work done by the string is basically force into distance into cos theta and all. But let us see what are the forces at play. Again, there is mg acting downward on this body. Okay, it is attached with a string, but it is not in equilibrium. It is given that this body is moving down at a rate a is equal to g by 4. These are things that are given in the question. Now, let's first of all find what is the t required for that. Of course, there is a direct equation for this. You know, if the body is actually being lowered, then the tension is directly given by T equal to m into g minus a. And in this case, it is m into g minus g by 4 because acceleration is g by 4. So m into g minus g by 4 is 3g by 4. In other words, it is 3mg divided by 4. So the tension we are using to support the body, okay, even though it is going down, a small support is given upward. That is 3mg by 4. Now the question says that in this way the body is allowed to fall through a distance of h. Now the question is, what is the work done by tension? What is the work done by tension? Okay, work done by tension is W equal to force into distance into cos theta. I can say it is Fs cos theta again, but the F here is nothing but T, and that T is 3mg divided by 4. Now S is h here. Now look at cos theta. See, the force is upward and the displacement is downward. So cos theta is 180. It's a negative work, remember. So that is going to be some cos of 180 here, which is minus 1. So finally, it is minus of 3mgh divided by 4. That's a work done by the tension here. Tension is doing a negative work here, obviously because you're allowing the body to go down while tension is acting upwards. So certainly the work is negative. So minus 3 by 4 mgh is your right answer. Your option is C. Moving on, question number 15. Based on a force displacement graph, a particle of mass 0.5 kg is subjected to a force which varies with distance as shown in the graph. The speed of the particle at x equal to 0 is 4 meter per second. Now, this experiment start ചെയ്യുമ്പോൾ തന്നെ ബോഡിക്ക് ഒരു വെലോസിറ്റി ഉണ്ട്, അത് 4 meter per second ആണ്. Then what is the speed at x equal to 8 meter? And look at the figure, where is 8? 8 meter പറഞ്ഞ ഫിഗറിൽ ഇവിടെയാണ്, ഇതാണ് 8 meter. ഗ്രാഫിന്റെ മുഴുവനില്ല. അപ്പോൾ ഇവിടെ നമുക്ക് ഇതുവരെയാണ് ഈ ക്വസ്റ്റൻ ഉള്ളത്. 8 പറയുമ്പോൾ ഇവിടെയാണ്. ഓക്കെ, ആ 8 meter ആകുമ്പോഴേക്കും what is the velocity is the question. You know, this is a force displacement graph. The advantage of having force displacement graph is that you can find easily the work done by the force. Work done by the force is simply the area under fx graph. അപ്പോൾ നിങ്ങൾക്ക് ഈ ഫോഴ്സ് എത്ര വർക്ക് ചെയ്തു ഇവർ പറഞ്ഞ സമയം കൊണ്ട് എന്നറിയാൻ അവർ പറഞ്ഞ പോയിന്റ് വരെയുള്ള ആ ഗ്രാഫിന്റെ ഏരിയ കണ്ടാൽ മതി. ഇതാണ് 8 സെക്കൻഡ് എങ്കിൽ അതുവരെയുള്ള ഗ്രാഫിന്റെ ഏരിയ. സോ വിൽ ബി ഫൈൻഡിങ് ദി ഏരിയ ഓഫ് ദ ഗ്രാഫ് ഇൻ ദിസ് പോർഷൻ. അതായിരിക്കും ആക്ച്വലി വർക്ക് ഡൺ ബൈ ദ ഫോഴ്സ്. Once you get work done, certainly final kinetic energy, final velocity, everything can be easily determined using work energy principle. Okay, so my first attempt is to find what is the area. Okay, area parayan I will just divide it accordingly. The 4 and this is given to be some 10. So the area of this part is very easy. It is half bh. So I can easily say that the area of this part is 20 joules. Now 8 second പറഞ്ഞ ഏതാണ്ട് ഫിഗറിൽ ഈ ഒരു പോയിന്റ് ആണ് 8. അപ്പോൾ അതുവരെയുള്ള സെപ്പറേറ്റ് ഏരിയ, ഓക്കെ, ദിസ് വൺ, ഇതൊരു റെക്ടാങ്കിൾ ആണ്. ഇറ്റ് ഇസ് ലെങ്ത് ഇൻറ്റു ബ്രെഡ്ത്ത്. ലെങ്ത് ഇസ് 4 ആൻഡ് ബ്രെഡ്ത്ത് ഇസ് 10. അപ്പോൾ ഒരു 40 അവിടെ ഉണ്ടാവും. സോ ദിസ് ഇസ് 40. ഇപ്പുറത്തെ ഭാഗം വേണ്ട. ഓക്കെ, ഇവിടെ ഏരിയ ഒക്കെ ഉണ്ടെങ്കിൽ പോലും ദ ക്വസ്റ്റൻ ഇസ് ഓൺലി അബൌട്ട് വെലോസിറ്റി അറ്റ് 8 seconds. അതുകൊണ്ട് ഞാൻ ഇവിടെ വരെയുള്ള ഈ മൊത്തം ഏരിയ മാത്രമേ എടുക്കുന്നുള്ളൂ. Say total work done by the force is given to be 40 plus 20, which is equal to 60 joules. So the work done by the force acting on the body is 60 joule. Now reminding you that according to work energy principle, the work done on a body is equal to change in kinetic energy. So it is half mv squared, mv2 squared minus half mv1 squared. Or I can say W equal to half m into v2 squared minus v1 squared, because the work done by force on a body is equal to change in kinetic energy. Okay, here is my calculation now. 60 is equal to half into, now in the question, m is said to be 0.5 kg. 0.5 kg means another half kg. That into v2 is to be determined minus v1 squared. They clearly say that initial velocity was 4 meter per second. So v1 was 4. So that is into 4 squared. Okay, 240 plus 16 is 256. 256 is equal to V2 squared. You'll get V2 by taking square root. You'll get V2 as 16 meter per second. Okay, because they ask you what's the velocity at t equal to 8 seconds. So we consider only area up to 8 seconds. Okay, 8 second, sorry, 8 meter. All right, answer is 16. You must go with option B. Okay, let me go to the next question. B is option. I go to 16. I'll make it fast. Under the action of a force, a 3 kg body moves such that x equal to t squared by 2, where the position is x and that is in meters and t is in seconds. Work done by the force in the first 3 seconds is. Again, they're asking you what's the work done by the force. Work done is also equal to change in kinetic energy according to work energy principle. So we will better find what is the change in kinetic energy of this body. You'll find the initial and final velocities. Thereby, you'll be able to find what's the change in kinetic energy also. Okay, but before that, let us see what is the velocity of the body. It is given that x is equal to t squared by 2. That's the way the body is moving. Finding equation for velocity is very easy mathematically because you know that v is equal to dx divided by dt. Now, in this case, it is dx by dt means in this case it is 2t divided by some 2. Or in other words, we'll get v as how much is that? Yes, t. Equation for v is very simple, v equal to t. Now, finding the velocity at 0 second and 3 seconds is also easy. Let me say velocity at 0 second is v1. Okay, and that v1 is supposed to be just t because t is 0, അതുകൊണ്ട് v1 value is 0 ആണ്. So initially velocity was 0 meter per second because v equal to t. Now final velocity is taken as v2. Velocity at 3 seconds is v2 and v equal to t, so therefore v2 equal to 3 meter per second. Now they ask you what is work required. Work is equal to half into, work is nothing but change in kinetic energy. It is half into m into v2 squared minus v1 squared, which is equal to half into mass of the body is 3 kg, that into v2 squared. v2 squared means it is a 3 squared, so 9 minus 0. 27 by 2, answer is 13.5 joules. 13.5 joules of work required, work done by the force. Your option is A. 16 was that. Moving on to 17. A block of mass m is released on the top of a smooth inclined plane of length x and inclination theta as shown in the figure. Horizontal surface is rough, while the inclined surface is perfectly smooth, but the horizontal surface is rough. If the block comes to rest after moving a distance of d on the horizontal surface, then the coefficient of friction between the block and the surface will be. It's about finding the coefficient of friction, but you'll again have to apply work energy principle. So this is how the body starts. It is starting from certain height. Let me just assume that h is a height from which it is starting. Now starting from this point, the body reaches here. ഇവിടെ എത്തുമ്പോഴേക്കും അത്യാവശ്യം velocity ബോഡിക്ക് കിട്ടിയിട്ടുണ്ടാവും because it is starting from a certain height. Let me suppose that the velocity when it reaches the bottom is v. അങ്ങനെയാണെങ്കിൽ this body has some half mv squared also. Now ഇവിടുന്ന് പോകുന്ന ബോഡി നല്ല സ്പീഡുള്ള ബോഡി പിന്നെ സ്പീഡ് കുറഞ്ഞ് ഏതാണ്ട് ഇവിടെ എത്തിയപ്പോൾ സ്റ്റോപ്പായി. അതുകൊണ്ട് final kinetic energy of the body is 0 joules. So there is a change in kinetic energy here. Half mv squared becomes 0 later. Okay. Now ഇവിടുന്ന് ഇവിടെ എത്തും വരെയുള്ള ആ ട്രിപ്പിൽ there was actually a force which was doing a work. ബോഡി ഇങ്ങോട്ട് മൂവ് ചെയ്യുമ്പോൾ there was a frictional force acting backward. ആ ഫ്രിക്ഷണൽ ഫോഴ്സ് ആ ബോഡി സ്റ്റോപ്പ് ചെയ്യും വരെ ഉണ്ട്. ആ ഫ്രിക്ഷണൽ ഫോഴ്സ് കൈനറ്റിക് ഫ്രിക്ഷൻ ആവാനാണ് ചാൻസ് ഉള്ളത്. ഞാൻ തൽക്കാലം FK എന്ന് വിളിക്കാം. ഓക്കെ, അത് ഈ ബോഡിയിൽ d ഡിസ്റ്റൻസ് വരെ ഉണ്ടായിരുന്നു. അപ്പോൾ ഫ്രിക്ഷണൽ ഫോഴ്സ് ചെയ്ത വർക്ക് FKD വെച്ച് നമുക്ക് കണ്ടുപിടിക്കാം. Now let's apply work energy principle. Total work done by all forces on the body is equal to change in kinetic energy. Let us see what is the work done by frictional force first. FK is acting backward but D is forward. Therefore, the work done by frictional force is that Fk into D, but it is minus because friction is backward, body is advancing forward, is equal to change in kinetic energy. Change in kinetic energy means final kinetic energy minus initial kinetic energy. So it is 0 minus half mv squared. Okay, negatives are cancelled to give you Fk into D is equal to half mv squared. Okay, this is work energy principle. Now let's go back. What is this half mv squared? ഈ ബോഡിക്ക് ഇവിടെയുള്ള കൈനറ്റിക് എനർജി എന്ന് പറയുന്നത് ഇവിടുന്ന് സ്റ്റാർട്ട് ചെയ്യുമ്പോഴത്തെ പൊട്ടൻഷ്യൽ എനർജിയാണ്. ഫോർ എക്സാമ്പിൾ, ഈ ബോഡി എച്ച് ഹൈറ്റ് നിന്നാണ് സ്റ്റാർട്ട് ചെയ്യുന്നതെങ്കിൽ ദ ബോഡി വാസ് പൊസസിങ് സം പൊട്ടൻഷ്യൽ എനർജി mgh. അത് തന്നെയാണ് പിന്നീട് ഹാഫ് mv² ആയത്. അതുകൊണ്ട് ഈ ഹാഫ് mv² പറഞ്ഞാൽ പഴയ mgh തന്നെയാണ്. സോ ദാറ്റ് ഇസ് വാട്ട് ഐ എം റൈറ്റിംഗ് നൗ. Fk that into d is equal to the mgh in the question. Now let me come to the final steps. What is this Fk? You know that Fk is nothing but mu into r, and r is nothing but mg here because it's a horizontal surface. So Fk is written as mu mg that into d is equal to mg into h. What is h here? Going back to the question, you'll see that h is nothing but x sine theta because it is said that this is the h. Okay, now this angle is given to be this angle is given to be theta, and the length of the plane is given to be x. So clearly this h is nothing but x sine theta because it's an opposite side. So let me rewrite this equation. This equation I'm rewriting mu mg d. Okay, mu mg that into d is equal to, it is mg into h. Okay, h was here. H is equal to x sine theta. Yes, here comes the answer. Mg is cancelled. They ask you what is mu. So here is the answer. It is x sine theta divided by d is your answer. So this is it. X sine theta by d, that is the coefficient of friction. You go with option C. So this one is right. That was 17. Okay, let me be fast. 18. A uniform chain of length 2 meters is kept on a table such that the length of 60 centimeters hangs freely from the edge of the table. The total mass of the chain is given to be 4 kg. What is the work done in pulling the entire chain onto the table? So part of chain is hanging on the table vertically and you are pulling the other end. Looks like this. ഇതാണ് തുടക്കം. Later, ഈ ഹാങ്ങിങ് പാർട്ടിനെ വലിച്ച് അവർ മുകളിലേക്ക് എത്തിച്ചു. സോ അതാണ് ഹാങ്ങിങ് പാർട്ട് എങ്കിൽ ഇതാണ് പിന്നീടത്തെ ഹാങ്ങിങ് പാർട്ട് ബിക്കോസ് യു ആർ പുള്ളിങ് ഇറ്റ് ലൈക്ക് ദിസ് സോ ദാറ്റ് ദ ഹാങ്ങിങ് പാർട്ട് ഈസ് നൗ ഓൺ ദ ടേബിൾ. What is the work required for that? That's the question. Basically, this question is easy because you are actually lifting this part and keeping it on the table. ഈ പാർട്ട് ലിഫ്റ്റ് എന്ന് പറഞ്ഞാൽ ആ പാർട്ടിന്റെ മാസിനെയാണ് ലിഫ്റ്റ് ചെയ്യുന്നത്. ആ പാർട്ടിന്റെ മാസ് എന്ന് പറഞ്ഞാൽ അതൊരു ചെയിനായ സ്ഥിതിക്ക് അതിന്റെ മാസ് എവിടെയാണ് കോൺസെൻട്രേറ്റഡ് എന്ന് പറയാൻ അറിയണം. You know that mass of any part that you study will be concentrated at center of mass. So here you must assume that the center of mass initially was here. Hanging part in the center of mass. അത് ഇവിടെ ആയിരുന്നു. അത് പിന്നീട് അതാ ഇതാണ് ഹാങ്ങിങ് പാർട്ട് എങ്കിൽ പിന്നീട് ഹാങ്ങിങ് പാർട്ട് ഇവിടെ എത്തിയല്ലോ എന്ന് പറയുമ്പോൾ ആ പറഞ്ഞ സെന്റർ ഓഫ് മാസ് ഇവിടെ എത്തിയിട്ടുണ്ടാവും. സോ സെന്റർ ഓഫ് മാസിന് ഒരു ലിഫ്റ്റ് ഉണ്ടായിട്ടുണ്ട്. സെന്റർ ഓഫ് മാസ് ഈ പൊസിഷനിലായിരുന്നു പിന്നീട് ഇവിടെ എത്തി. സോ ഇവിടെ ഉണ്ടായിരുന്ന സെന്റർ ഓഫ് മാസ് ഇവിടേക്ക് കയറി എന്നർത്ഥം. എങ്കിൽ ഈ സെന്റർ ഓഫ് മാസ് എത്ര എച്ച് ഹൈറ്റ് മുകളിലേക്ക് കയറിയിട്ടുണ്ടോ അത് വെച്ചിട്ട് വർക്ക് കണ്ടുപിടിക്കാവുന്നേ ഉള്ളൂ. If m is the mass of center of mass and h is the lift that is given, then the work is simply mg that into h. This is what we are going to use. Okay? അതിന് വേണ്ടത് രണ്ട് കാര്യങ്ങളാണ്. ഒന്ന്, ഈ m എത്രയുണ്ട്, what's the mass, value of mass. ഈ m എത്രയുണ്ട്, that is to be determined. m എന്ന് പറഞ്ഞാൽ ഉദ്ദേശിച്ചത് ഈ കാണുന്ന ഹാങ്ങിങ് പാർട്ടിന്റെ മാസ് ആണ്. ഹാങ്ങിങ് പാർട്ടിന്റെ മാസ് നേരിട്ട് ഒരു പറഞ്ഞിട്ടില്ല. റീഡ് ദ ക്വസ്റ്റ്യൻ വെരി കെയർഫുള്ളി ആൻഡ് സി. ഈ ക്വസ്റ്റ്യനിൽ they say that 2 meters the length of the full chain. Look at this. 2 meter length total length ആണ്. അതിൽ 60 സെന്റിമീറ്റർ ആണ് ഹാങ് ചെയ്യുന്നത്. അപ്പൊ 2 മീറ്റർ ലെങ്ത്തിലാണ് 4 kg മാസ് ഉള്ളത്. അപ്പൊ 4 kg 2 മീറ്ററിലാണെങ്കിൽ 60 സെന്റിമീറ്ററിൽ എത്ര മാസ് എന്ന് യൂണിറ്ററി മെത്തേഡ് വെച്ച് പറയേണ്ടി വരും. ഐ വിൽ മേക്ക് ഇറ്റ് ഈസി ഫോർ യു. ശരിക്കും 200 സെന്റിമീറ്റർ ആണല്ലോ 2 മീറ്റർ എന്ന് പറഞ്ഞാൽ. ആ 200 സെന്റിമീറ്ററിൽ മൊത്തം 4 kg ഉണ്ട്. Therefore, 1 centimeter will have a 4 divided by 200 kg. Therefore, 60 centimeter, they ask you what's the mass of 60 centimeter. That will be 4 by 200, that into 60. In other words, it is 24 by 20. 24 divided by 20 kg parnal, I think it is 6 by 5 kg. Yes, so the mass m of the hanging part is 6 by 5 kg. That's the mass that is hanging. Okay. Now this has to be lifted to what height? ഈ കാണുന്ന സെന്റർ ഓഫ് മാസിനെ എവിടെ എത്തിക്കണം എന്നാണല്ലോ എന്ന് പറയുമ്പോൾ ഇതാണ് എച്ച്. ദാറ്റ് ഈസ് ഈസി ബിക്കോസ് ഈ ലെങ്ത് മൊത്തത്തിൽ 60 സെന്റിമീറ്ററാണ്. ഇഫ് ദാറ്റ് ഈസ് 60 ദെൻ ദ ലിഫ്റ്റ് ഇവിടുന്ന് ഇവിടേക്ക് എത്തിക്കാൻ ആവശ്യമായിട്ടുള്ള ഡിസ്റ്റൻസ് ദാറ്റ് ഈസ് ഗോയിങ് ടു ബി ഓൺലി 30. അപ്പോൾ ഈ ഡിസ്റ്റൻസ് വലിയ പ്രയാസമില്ല. ഓക്കെ, ദിസ് വൺ ദാറ്റ് ഈസ് 30 സെന്റിമീറ്റർ. ഓക്കെ, 30. So the work required is going to be mgh. That is what I'm going to finally find. M I told you is 6 by 5. G is okay taken as 10 and 30 centimeters height. 30 centimeter പറഞ്ഞ meter ആക്കി പറ്റൂ. So when it is 30 centimeter, it is 0.3 meter. Okay. 10 and 5 cancel 2. So it is going to be 12 into 0.3, which is 3.6 joules. That's the work required to lift the chain in the figure. That is 3.6 joules. Okay, that was question number 16. Sorry, 18. This is question number 19. Simple question, I think, so we can be a little fast. Two particles of masses of 1 kg and 3 kg have position vectors 2i plus 3j minus 2k and minus 2i plus 3j minus 2k respectively. What is the position of center of mass? Position vector of center of mass. It's a direct question from center of mass. If you have two masses, for example, m1 sitting here, m2 sitting here, and if their corresponding position vectors are r1 and r2, then the center of mass can be somewhere here. This can be the location of center of mass. And that location of center of mass is given by certain expression. If I'm saying this is the position vector RCM, then that is given by certain expression, you know. You must get it by heart. RCM is equal to, simple, it is m1 into r1 plus m2 r2 divided by m1 plus m2. This is the position vector of center of mass. It's direct application. Let me put without mistakes. 1 kg into m1 is 1, that into r1 is 2i plus 3j minus 2k. Hoping that there is no printing error in this. Okay, plus m2 is okay 3 into, how much is that? Minus of 2i plus 3j minus 2k. Okay, that is m2 r2 divided by total mass 1 plus 3, which is 4. Okay, this is equal to, it is 2i, let me simplify this, 2i plus 3j minus 2k, then comes minus 6i, then plus 9j, then I have minus of 6k divided by total mass 10. Okay, so 2i and 6i, it is minus of, sorry, not 10, I'm sorry, it is 4. Okay, it is 4. Minus 2i minus 6, 2i minus 6i minus of 4i. Then I have 12j and minus of how much? Minus of 8k divided by some 4, which is equal to minus of I plus 3j minus 2k. That's the answer. Minus I plus 3j minus 2k, which is that? Minus I plus 3j minus 2k. You go with option B. That was straight and easy. Question number 20 is also based on finding the location of center of mass. The coordinate of center of mass of system is shown in the figure. What you're seeing here are actually huge bodies. Maybe these are spheres but identical. All are having same mass and their own centers are located at the points shown in the figure. You're finding the location of position of center of mass. Again, these may be huge bodies, but you know their masses are concentrated at their own centers. So you can believe that they are point masses. I'll assume that this is the point at which mass m1 is kept. So that is supposed to be some 0a. The coordinate is 0a for that. This mass is at origin and you know that is obviously 0, 0. And this mass m is at a0 as well. Now they ask you the location of center of mass. You know that the coordinate of center of mass is given by xcm is equal to m1 x1 plus m2 x2 plus m3 x3 for x coordinate by sum of masses m1 plus m2 plus m3. Okay, this is equal to m1, I begin with this. Okay, m1 x1 is okay 0 plus m2 x2 is 0 plus m3 x3 is ma divided by total mass is 3m. So that gives you a by 3. In a similar way, you'll get a ICM also. A similar equation, m1 y1 plus m2 y2 plus m3 y3 by total mass. That also will give you the same value, a by 3. And you will see that the coordinates are a by 3 and a by 3. You must go with option C. 21. Two bodies of masses 6 kg and 4 kg have their velocities 5i minus 2j plus 10k and 10i minus 2j plus 5k respectively. Then the velocity of their center of mass will be. This is about VCM. Two bodies are supposed to have two velocities. Example again, m1 is mass of this body, it is given some velocity v1. m2 is mass of this, let us say v2 is the velocity of that. Then the center of mass may be somewhere here. This can be the location of center of mass. That will be having its own velocity, and let us say that is VCM. That VCM is what they are asking. Okay. Again, you know that velocity of center of mass is given by again similar equation, m1 v1 plus m2 v2 in vector forms divided by total mass, that is m1 plus m2. Let me carefully put values. m1 into, okay, m1 is this, let us not make a mistake. m1 is this and v1 is this. So let me put values, okay, 6 into 5i minus 2j plus 10k, that is m1 v1, plus m2 is said to be 4 kg into 10i minus 2j plus 5k. That divided by total mass is, okay, 10 kg. Okay, this is equal to 6 into 5, 30i minus 12j plus 60k plus 40i minus 8j plus 20k by total mass 10 equal to 30 plus 40, I have 70i, then j minus of 20j, okay, minus 20j, then I have 80k plus 80k whole divided by 10. So what is that? It is 7i first minus 2j, okay, finally 8k also. So that's the velocity of center of mass, which is at 7 minus 2, 8. Your option is C. This one is correct. 21. I move on to question number 22. If the system is released, then the acceleration of center of mass of system will be. It's a two-body system. M at one side, 3m on the other side. You know that the system will accelerate under gravity. But they ask you, what is the acceleration of center of mass? For example, if this is a system, let me assume that m1 is sitting here, m2 is here. Now, you know, since m2 is greater than m1, m2 will accelerate down with a rate of a, and m1 will be rising up with the same acceleration a. But they don't ask you what is a. They ask you what is the acceleration of center of mass. Maybe this is the location of center of mass. It may be moving down, possibly. Okay, they ask you what is that ACM. That's what they ask. Now, you know, acceleration of center of mass is also given by a very similar expression. If you have forgotten, here is my reminder. ACM is equal to m1 a1 plus m2 a2 divided by total mass m1 plus m2. That's also a very similar equation. But we need a for all these. What is the value of acceleration? That is to be determined first. But you know, this is a two-body system. Finding the acceleration of system is very easy for two-body system. I remind you of again that equation, m2 minus m1g by m1 plus m2. That's a way to find the acceleration of a two-body system. Here it is, m2 is 3m in our question, minus m1 is m, that into g divided by 3m plus m. That is actually acceleration. So 3m minus m is 2m. So 2mg divided by, okay, it is 2mg on the top divided by 4m. So how much is that? G by 2. I think it is g by 2. Yes, acceleration A of the system is g by 2. So let me start putting values. Hope that I am not wrong. Okay, ACM is equal to m1 a1 means this m into a, and a is g by 2. So I have m into g by 2. This is upward, minus m2 is 3m in our case. So 3m into, it is again g by 2. Okay, divided by m1 plus m2 is m plus m, that is 4m. Okay, simplify this. So this is going to be 3mg by 2 minus mg by 2 is equal to mg by 2. M is gone. mg by 2 divided by 4. No. 3mg by 2 minus mg by 2 is mg. So g divided by 4. Minus actually. Minus of g by 4 indicates that the center of mass is going down. Okay. But the magnitude is what they are asking. You can go with g by 4. So your option is g by 4. It is A. 22. Moving on to 23. A particle of mass 3m is projected from ground at some angle with horizontal. The horizontal range is said to be R, capital R. At the highest point of its path, it breaks into two pieces, m and 2m. The smaller mass comes to rest, and the larger mass finally falls at a distance x away from the point of projection. then what is x? So it's a body that is projected obliquely in air, and at the highest point of the trajectory, the body breaks or explodes. Two pieces are formed. One is small m, and because of the impact of explosion, that small m is brought to rest. Its velocity is reduced to 0. And naturally, if its velocity is reduced to 0, it will be freely falling down. Now they ask you, where is the location of 2m? Because 2m is actually flying still, and where will it land? That's the question. Okay, here is it. This is the body. Let me assume that the mass of the body is some m, അല്ലെങ്കിൽ 3m, whatever it is. You can assume it is 3m. And at that moment, it was moving actually at the highest point. It is now that the body explodes. So explosion is shown in this figure. ആ എക്സ്പ്ലോഷനിൽ രണ്ട് masses ഉണ്ടായി, രണ്ട് pieces ഉണ്ടായി. One piece is having a mass m, the other piece is having 2m mass. Now they say that the mass, smaller mass, the velocity of that is reduced to 0. എന്ന് പറയുമ്പോൾ ആ ബോഡിക്ക് അവിടെ നിൽക്കാൻ സാധിക്കില്ല. Certainly it will go down. താഴത്തേക്ക് അത് വീഴും. Finally, in the end of the experiment, you will see that this small m is landed here. അത് ഇവിടെ ഉണ്ടാവും. But this 2m is still flying. It may be falling somewhere here. Chance. So I have shown that in the next figure. Look at this. Ivideana body potithirchadu. Adilte small m mass thalekku veenu. So in the end, you can expect small m here. And ividunnu therichu poya larger 2m mass ulla body adanu ivide veenathu. Okay. So this is 2m. Maybe it has taken a path like this. Okay, I'm showing that possibly this is the path taken by 2m. Now they ask you, where is 2m falling? Now you know one thing. M and 2m you know that even after explosion, the center of mass of the system will be continuing to move along the same expected parabolic path. So in the end of the experiment, you will see that the center of mass is here, exactly here. So center of mass ഇവിടെയാണെങ്കിൽ പിന്നെ 2m എവിടെയാണെന്ന് പറയാൻ വലിയ പ്രയാസമില്ല, because in this question it is said that r is a range. The full range, ഈ distance questionൽ r ആണെന്ന് പറയുന്നു. അപ്പോൾ പിന്നെ ഈ distance, that's very clear, that distance is r by 2. Okay, that is r by 2 because it is half the range. പിന്നെ ഈ distance ആണ് കാണേണ്ടത്. What is this distance is what they're asking. Let me call it x. Now you know it's a two-body system. If the center of mass ആണെങ്കിൽ, you know that m1 into d1 must be equal to m2 into d2. That is where the location of center of mass is always located. അതുകൊണ്ട് തന്നെ ഇത് രണ്ട് equate ചെയ്താൽ x ഒരു സ്റ്റെപ്പിൽ കിട്ടും. So I'm writing that m into r by 2 is equal to 2m that into x. Solving this, you'll get x as r by 4. ഈ distance r by 4 ആണ്. So r by 4 from this point. But I think we must visit the question again and see what's the distance they're asking. ഈ distance ആണ് ചോദിച്ചത്. ഇത് അതെന്ന് പറയുമ്പോൾ ഇതുവരെ r ഉണ്ട്, പിന്നെ ഒരു r by 4 കൂടി ഉണ്ട്. So total distance is going to be r plus r by 4. That's the final distance. R plus r by 4. Let us see. The full distance now is equal to r plus r by 4, because they're asking you what's the distance to object from the starting point. R plus r by 4 is 5r divided by 4. So 5r by 4, your option is C. That was 23. Okay, 24. The moment of inertia for a uniform circular disk about its diameter is 200 grams centimeter squared. Then its moment of inertia about axis passing through the center and perpendicular to circular face is. It's about comparing moment of inertia of same body about two axes. It's a disk. They say that when the disk is rotated, as per the figure, see, this is the way disk is rotated in the beginning. ഇങ്ങനെ rotate ചെയ്യുമ്പോൾ the moment of inertia I, they say that it is equal to some 200 units. And you know that if m is the mass of the disk and r is the radius, then I for that is actually mr squared divided by 4. Equations by heart ചെയ്യണം. Disk ആണ്, diameter ആണ്. ആ iന്റെ value ആണ് അവർ പറഞ്ഞിട്ടുള്ള 200. So 200 is actually mr squared by 4. That is the first hint given. Now the same disk is rotated in a different way in the next part of the question. They ask you what is the I dash now. You know that when the disk is rotated in this way, the moment of inertia is mr squared divided by 2. Yes. Now they ask you what is the value, because you know mr squared by 4 ആണല്ലോ 200. അപ്പോൾ mr squared by 2 എന്ന് പറഞ്ഞാൽ അതിന്റെ twice ഉണ്ടാവും സ്വാഭാവികമായിട്ടും. When you compare these two, you will see that it is I dash is equal to 200 into 2, which is equal to 400 units. That is the answer. 400 CGS units is the answer. Okay, you can go with C. Okay, there is a J here. That's wrong. Okay, correct it and C. It is 400. All right, 25. Again, based on moment of inertia. Moment of inertia of the shown uniform L-shaped rod of mass M, total mass M, and rotating about the shown axis. It's a full rod bent in the form of some L and all, but the total mass is supposed to be 2m, sorry, m. Let us see what is the moment of inertia about this axis. See, the whole thing is rotated about this axis. First of all, when a rod is rotated in this way, see, look at this part of the rod. This rod, this axis about moment of inertia 0 because it's a thin rod. When it is rotating about its own axis, passing through the length, its moment of inertia is 0. But this part has a moment of inertia. This is m and this is length and that's a moment of inertia. Okay. Now for the moment I'm saying that this part, okay, I'm saying this part is having a mass of capital M. Question small m area, okay. I'll use capital M for the mass of this part alone. This is mass capital M. Okay. That mass in the value calculation because okay, low battery for what? Okay. Total mass, okay, total mass is given to be some small m. So remember, 3L length has a mass of m here because they say that the total mass of the rod is actually small m. Our total mass is 2L, so 2L plus L, that is 3L. 3L has mass m. L length, you know that m by 3 is the mass. This length is 2L. But 2L length, you know the mass is 2m divided by 3. So the mass of the remaining portion or the vertical portion of the rod is actually 2m divided by 3. That's the mass. Now length L, you know that is given to be 2L in the question. Now they ask you what's the moment of inertia about this axis. When the system is rotated about this axis, you know, this rod will rotate about end. This rod this end about rotate here. When rod is rotating about one end, you know that moment of inertia is ml squared by 3. Now it's only a matter of putting values. This capital M is a 2m by 3 in my question, that into L is okay 2L, so whole squared divided by 3. So you have some 2 into 4, 8, and finally it is 8 by 9 times ml squared. 8 by 9 times ml squared. That's right. Your option is A. Okay, because the mass of this part is actually 2m by 3 and length is L. Actually, equation is this. Because if this is the length L, it is ml squared divided by 3. Okay, that was question number 25. Okay, let me move on to 26. Okay, again, I have a battery issue. I have only 9% remaining. Please wait again. Eh? Please give me 1 minute. I'll be back. Moin. Tablet charge. Tablet charger on the Okay, let me continue. Okay, 26 is my next question. Two rings of same radius r and a small m mass are placed such that the centers are at common point and their planes are perpendicular to each other. Moment of inertia of the system about an axis passing through the center and perpendicular to plane of the ring will be. See, in the question there are two rings. There is no diagram given. You must read the question very carefully and understand how the diagram looks like. There are two rings. They have a common center, but their planes are not common. They have two planes in mutually perpendicular directions. So altogether the system looks like this. This is first ring. One ring is this. Whose center is this? On the left. One second, eh? You know. No. Okay, let us continue. These are the two rings mentioned in the question. They have a common center, as I told you, but their planes are not perpendicular, so it looks like this. So this is a combination of rings. M is the mass of the first ring, R is radius, is an identical ring. So M is mass of the other ring also with radius R. They ask you, what is the moment of inertia of system about an axis like this? So I'm just showing an axis here. If you rotate the whole system about this axis, what is the moment of inertia is a question. So let's do one thing. Let us find separately the moment of inertia of each part. I'm showing it here. This is the full part of the system. I have just divided it. This is one part, and this part has a moment of inertia. Let's see how much. M is mass, R is radius. Then the moment of inertia of this part, is I is equal to, maybe I'm calling I1. That is equal to mr squared because it is a ring rotating about its center and the axis is passing perpendicular to plane of ring. Now second ring has a mass of m again, r is a radius. But for second ring, the same axis is acting at a diameter. If it is diameter, then moment of inertia I, let me call it I2. That's given by another expression, and it is mr squared divided by 2 also. They ask you what's the total moment of inertia. So it is I is equal to I1 plus I2. It is mr squared plus here mr squared divided by 2. Simple. It is 3 mr squared by 2. That's the moment of inertia of the combined system. So mr squared by 2 plus mr squared, it is C. Your option is C. Okay. Okay, friends, that was question number 26. So sorry for these technical issues. Please forgive me for that. I know you're late. We have 3 more questions. I'll finish that with the question number 30. Here is 27. A wheel starting with angular velocity of 10 radian per second acquires angular velocity of 100 radian per second in 15 seconds. If the moment of inertia is 10 kg meter squared, then the applied torque is. There is a ring which is rotating with a certain angular velocity. Okay. I think something is missing. I lost tab, I think. Again, some issues. Let's wait. Please wait. I lost the connection to the tab, I think. Please wait. Let me try myself. I think I lost the visuals from tab. Again, let me call my technician. Please wait. Wait. Mini boy. Tab boy. Tab and the display boy. No. ಇಲ್ಲ. Delay it now. Thank you. All right, friends, let me come back to question number 27. All right. A wheel starting with angular velocity of 10 radian per second. So please confirm that you can see the tab now. I'm discussing 27. Will anyone give me some yes or hi or okay? I'm waiting for your reply. Question number 27 is on display, but is it visible? Okay, thank you. A wheel starting with angular velocity of 10 radian per second acquires the angular velocity of 100 radian per second in 15 seconds. The moment of inertia is given to be 10 kg meter squared. Then the applied torque is. So here is a wheel that was rotating slowly. Later, it is speeding up to a speed of 100 radian per second. Now, what is the torque required for that? That's a question. Angular velocity 15 100 ആയെങ്കിൽ അതിന്റെ പുറകിൽ ഒരു torque ഉണ്ട്. Torque ആണ് അതിന്റെ velocity കൂട്ടിയത്. They ask you what is the torque. And you know, finding torque is easy as far as a body rotating about fixed axis is concerned. Finding torque is simple as tau equal to I into alpha. Now, I is straight away given in the question as 10 kg meter squared. Only thing that is missing is alpha. What is the angular acceleration given to this body? But you can easily calculate it because in this case, angular velocity changes from omega 1 to omega 2 in a time t. You know that in that case, angular acceleration is omega 2 minus omega 1 by t. That's the best way to find angular acceleration. And here it is, 100 radian was the final angular velocity. Initially, it was only 15 divided by, no. Initially, it was not 15, it was 10, I think, isn't it? Yes, 100. 10 divided by 15 seconds. So this is the way I can find angular acceleration. So 90 divided by 15. How much is that? Yes, it is 6. So angular acceleration is 6 radian per second squared. That is alpha. Now it's easy. Torque is equal to I is given to be 10 and they say 6 is we got 6 as the angular acceleration. So the torque is going to be, yes, 60 Newton meter, 60 units, SI units. That is right. That was question number 27. Okay, here is 28th question. A uniform rod of length L and mass M has a point mass M at its end. The rod is free to rotate in vertical plane about A. The rod initially in a horizontal position is released. The initial angular acceleration of the rod about A is. So please understand how the figure looks like. I have a better figure for you. Just look at the next page. This is how it looks like. This is the assembly. There is a rod here and mass of the rod is M. This particle is also having a mass M. The particle, please consider this as a particle only. Heavy size. So M is a mass of this is M. Now this is being pivoted like this. But pivot. Now if you're releasing it, this will go down like a pendulum. Okay, like a compound pendulum, it may go down. But initially, it's horizontal. Now they ask you, the moment you release it, what is the angular acceleration of the assembly? That's a question. Now it is about angular acceleration. So I remind you of again that tau equal to I alpha. Therefore, alpha will be equal to tau by I. Simple as this. You find what is the torque about the pivot. You find what is the I of the system about the pivot. Just divide it. Simple as that. Alpha is tau by I. Now let us see what is tau. It is gravitational force acting on the system which constitutes a torque. So you must be very clear here. This system has a total mass of 2m because m is a mass of this part and 2m is, m is a mass of the particle also. So the total mass is 2m. But where is that 2m located? You must be very clear. The mass of a system is supposed to be concentrated at the center of mass. So in order to mark the weight of the system, you must identify where exactly the center of mass is. But that's very easy because this rod in the center of mass is M. Particle in the center of mass is M. Our common center of mass is So 2m will be certainly located here because these two bodies are having equal mass. This is the location of center of mass. So I am showing that position. Okay, in case of any doubt, please comment. This is one center of mass M. This is the center of mass M. Then a common center of mass. This is the point. Okay, this green point I am showing here is actually the location of center of mass. Okay, our distance. Let's see what is that distance. This distance. Distance. Torque. So that distance, length is given to be L. L by 2 distance. L by 4. So the total distance is L by 2 plus L by 4, which is 3L by 4. That is a distance. So I am noting that distance here. Okay. This distance is 3L divided by 4. That is a distance to center of mass from the pivot. Okay, now it is at that point the weight of the system is acting. So the mg of the system is acting there. Now mg means it is total mg of the system. Total mg പറഞ്ഞാൽ 2m ഉണ്ട്. ഈ പറഞ്ഞ പോയിന്റിന്റെ മാസ് തന്നെ 2m ആണ്, സെന്റർ ഓഫ് മാസിന്റെ. അതുകൊണ്ട് തന്നെ ഇവിടെ ആക്ട് ചെയ്യുന്ന ഫോഴ്സ് വേറെ mg അല്ല, 2mg, because 2m is the mass of center of mass. Okay, now 2 mg is acting there. At what distance you see? 2 mg is acting at a distance of 3L by 4. So the torque about this point is going to be this force into this distance. So let me write what is torque here. Torque is equal to 2 mg the force, that into lever arm or shortest distance, that is 3L divided by 4. So how much is that? Torque is going to be 3 mg divided by 2. Okay, 3 mg by 2 times L, that is torque. So torque is that. Now let us find what is I. Okay, let me confirm that I did not make mistake. 2 mg is a force into 3L by 4. 2 and 4 cancel, correct. Okay, now we come to moment of inertia. System has a moment of inertia. What is that? Let us see. Moment of inertia of system is moment of inertia of rod plus moment of inertia of particle. So let me write what is I here. What is moment of inertia of rod about this point? You know the rod is rotating about one end. So the rod will be having a moment of inertia of ml squared divided by 3. That is a moment of inertia of rod. Plus moment of inertia of particle. Particle has a moment of inertia of mr squared, where r is a distance. And r in this case is ml squared. L is the distance because this distance is L. So ml squared by 3 plus ml squared is 1 plus 1 by 3, which is 4 by 3. So I get this as 4 by 3 times ml squared as I. Now let's find what is alpha, the angular acceleration. It is alpha 3 mg, that L divided by 2. Okay, by I, or I can say into, okay, into 3 by 4 times ml squared. Okay, this is tau by I. This gives me some value. It is 9 by 8. Okay, 9 by 8 times g by L. Okay, the remaining terms are cancelled. 9 by 8 g by L is your answer. That was question number 28. Okay, let me go to the next question. I have two more questions for you. Question number 29. A circular ring of wire of mass m and radius r is making n revolutions per second about an axis passing through point on the rim and perpendicular to the plane. The kinetic energy of rotation of the ring is given by what? It's simple, because it's rotating body about a fixed axis. As long as a body is rotating about a fixed axis, the kinetic energy is given by a very simple expression. You know that kinetic energy E in such case is half into I into omega squared. It is simple as that. Only difficulty is in finding what is I and omega. This is a ring, and you know ring is rotating about a perpendicular tangent. If it is mr squared for ring here, about this axis it is going to be mr squared plus ma squared, which is going to be 2mr squared. So the moment of inertia of the ring is given to be 2mr squared. So let me put values, half into 2 times mr squared, because that is a moment of inertia part, that into omega. They don't give you omega directly. Instead, they give you frequency. But you know that omega is equal to 2 pi n. Therefore, omega squared is going to be 4 pi squared into n squared. So the 2 and 2 gets cancelled here. So finally, answer is 4mr squared, that into some pi squared, that into n squared. That is kinetic energy. Okay, I think the option is A, 4 pi squared mr squared n squared. My friends, here is my last question. With that, we wind up the session. A uniform thin ring of mass 0.4 kg rolls without slipping on a horizontal surface with a linear velocity of 10 centimeter per second. Kinetic energy of the ring is. Remember, this is a rolling body. You should know how to calculate the kinetic energy of a rolling body. If it is rolling without slipping, you know, the equation is given by certain. Okay, the value of kinetic energy is given by certain expression. I'm writing it here. E is equal to, it is half into m into VCM squared. That into, if there is no slipping, then this is the fact, that into 1 plus k squared divided by r squared. This is a full equation for kinetic energy of any rolling body, provided slipping is absent. Okay, now let me come to values. It is half into m. Mass of the body or ring is given to be 0.4 kg. So that is okay, 0.4 into VCM. Velocity of center of mass is given to be 10 centimeter per second. But you must use SI unit here. 10 centimeter per second means 0.1. So 0.1 into, 0.1 square, that gives you 0.01, because VCM is 0.1. So that becomes 0.01, that into 1 plus. Now k squared by r squared. K squared by r squared for different bodies, you must remember, If it is a ring, I'm reminding you that k squared by r squared for a ring is 1. K squared by r squared for a disk is 1 by 2. For a solid sphere, it is 2 by 5. But for a ring, it is 1. So k squared by r squared is 1 for a ring. So this is it. So totally, it is 2 and 2 will cancel. 0.4 into 0.01 is going to be 0.004. That much joules. Okay, this is equal to 4 into 10 raised to minus of 3, that much joules. 4 into 10 raised to minus 3 joules, that is the correct answer. Okay, my friends, these were my 30 questions. I thank you for watching. I assure you that I will be back with other chapters. I don't know which chapters anyway. We'll be meeting again. So once again, thank you very much for watching. Sorry for some technical difficulties and we had some delay also. My apologies for that. Wish you good luck and have a nice day, my friends. Thank you. Bye. Take care.